First one is an ordered pair. And really all an ordered pair is a point, right? And we usually represent that point x comma y. Next vocab word is a relation. And a relation is a set of ordered pairs. Of real numbers. So an example would be if I gave you a set of points including 1, 2, 4, -7, a half or a third, 2, that is a relation. So let's change this to a decimal. Let's put this 0.4 just to show you that you can have fractions and decimals in ordered pairs, as long as the decimal, oh, it's fine. Yeah, it's fractions and decimals. Next vocab word is domain. Who remembers domain? Is it X or Y? Charlie? X. Domain are the X values. So if we look at the example above, what's the domain in that relation I just listed? What's the domain in that relation I just listed? Well, it's 1, 4, and 1/3. That's the domain. So you go to, if I gave you a set of points, it's all the X values. And if domain are the X values, what's the range? The Y values. So if we go back to that relation I had listed and I wanted to know the domain of that specific relation, the domain would be 2, -7, and 0.4. Okay, here's a big one. So let's highlight all these vocabulary words. Next one is a function. I don't know why this is always such a hard concept. I'll try to simplify it for us. I'll give you the definition, but then I'll try to simplify it. So in order for something to be considered a function, every input, so I'm going to say in parentheses domain, so every input that we're pulling from the domain has exactly one output, meaning the range. Now, what does this mean? It means that we cannot repeat X values. What does that imply if I just say we cannot repeat X values? Can we repeat Y values? Yeah, we can repeat Y values. So how does this work? When I was in school, I actually remember my teacher used something and it stuck. My teacher said, each person has exactly one birthday, right? My birthday is June 23rd. That was the day I was born. I cannot have my birthday on June 23rd and my birthday also on August 12th. That doesn't work, right? Each person has just one birthday, but can multiple people land on the same birthday? Yeah, my birthday is June 23rd. Somebody else's birthday could also be June 23rd. That's okay. But me alone cannot have multiple birthdays, but multiple people can share the same birthday. And I always remember that's sort of how functions work. Every X has its own Y, but multiple X's can share the same Y. That's how that works. All right, so let's practice. Let's say simple problems. Let's say I gave you a relation with the points 2, 0, 7, 1, 3, 1, negative 2, 5. And now, based on that relation, I want us to identify the domain of this relation. So again, to identify the domain of this relation, it's just the X values. So we're going to have 2, 7, 3, negative 2. The order does not matter the way you list them. Now I'm going to list the range of this relation. So it's 0, 1. Do you think I need to put 1 again since it's repeated? No, we only need to put it one time, and then a 5. And now I'm going to ask, is this relation a function? Yes or no? Yeah, it is a function. Why? Why is this a function? Because we don't repeat what? Any X values. We do not repeat any X values. So this is a function because I do not repeat any X values. I did repeat the 1. Is that okay? Yeah, that's absolutely okay. Okay, now we're going to talk about the vertical line test. So if a vertical line intersects a relation at more than one point, the relation is not a function. Example. Let's say I have a circle. Okay, so here is a circle, and I want to know, is the relation a function? So when we're given a graph and we're asked, is the relation a function, what we're going to do is we're going to perform the vertical line test. I'm actually going to erase these because it got a little sloppy. So when I perform the vertical line test, I literally go to my graph and I draw vertical lines. And notice this vertical line that I drew touches my graph in more than one spot. Because it touches my graph in more than one spot, that tells me, oh, that's not good. Did I break it? What's wrong? It's okay. Why'd you guys say whoa?
The board like this.
Oh, did it?
Yeah.
Okay. It's still recording though. All right, we're safe. Okay. So what am I doing here? So because my vertical line has touched my relation in more than one spot, that means I'm repeating an x. Because look, if it touches here, isn't the point up here -1, whatever that is, right? And the point here also -1 something. So that means I'm repeating an x value. This whole line is -1, -1, -1, -1, comma something else, right? So if the vertical line touches our graph in more than one spot, it tells me I'm repeating an x value. And if I'm repeating an x value, is it a function? No. So is this a relation of function? We're going to say no. And my reason is it fails the vertical line test. So that was A. Now let's see this one. So just the line y equals x. Hey, is this relation a function? Yeah, because it passes the vertical line test. So we're going to say yes, comma, passes the vertical line test. Okay, let's keep going. Let's do another one. Let's say I have a list of my x coordinates, a list of my y coordinates. So I have 1, 2, 3, 4, and then I have 1, 4, 9, 16. And the arrow shows which x coordinate corresponds to which y coordinate. So we're going to say 1, 1, 2, 4, 3, 9, 4, 16. Is this a function? Yeah, because every x has exactly one y. We're not repeating any x. So we're going to say yes. Okay, the next one. Again, here are my x's, here are my y's. 1, 4, 2, 3, 5. So we're going to say 1 goes to 2, 1 goes to 3, 4 goes to 5. Is this a function? Yes? No? Maybe? No, this is not a function because every my X is my input, my Y is my output. So I'm inputting 1 and I'm getting 2, but then I'm inputting 1 again and I'm getting 3. So what is this telling me? That my inputs are repeating. Every input means exactly one output. This person can't be born on the second and the third. Can't happen. Okay. So this is not a function. Every input needs exactly one output. So no. And the last one of these. Is this a function? Yeah, this is absolutely a function. So this is saying person 1 was born on the second and person -1 was born on the second. That's okay. We can both be born on the same day, but we can both be born on the same day, but one person can't be born on multiple days. So that's okay. So you cannot repeat the input, but you can repeat the output. That's fine. So this is saying if I'm inputting 1 into some function, I'm getting out 2. If I'm inputting -1 into a different function, I'm getting 2. That's okay. Okay, so now I want us to, this was example 1. Example 2, I want us to determine the domain, range, and if the relation is a function. Okay, so for the domain, remember, we said the domain are the x values. Do we agree? So when we have a coordinate plane, the horizontal axis is our x-axis, the vertical axis is our y-axis. Now, is there a way I can possibly list all the x coordinates in this graph? There is no way to possibly list all the x coordinates because even besides the fact that there's arrows here, even if these were closed circles or open circles from within these 2 points, aren't there an infinite amount of points between them? I mean, can I keep breaking down a number into a fractional part, into another fractional part, into another fractional part? So there's no way if I give you a graph, so if I give you something that's not just a set of points, that you can possibly list the correct domain in there. There's no way you can't do it. So now what we're going to do is we're going to write the interval that the domain can exist in. So domain is the x. So we always start left to right. So I look, what's the furthest left this graph is going? The furthest left this graph is going is this arrow. What does that mean? It's going left for what? Forever. How do we represent forever in the negative direction? Negative infinity. And then, so you look furthest left to the furthest right. What's the furthest right this graph is going? Again, another arrow, but this time it's not going in negative infinity direction. It's going in positive. So there's 2 ways that we have to know how to write this. So remember set and interval notation. Do you guys remember those 2 notations? So we're going to first write it out in set notation. set notation is going to be x such that negative infinity is less than x, which is less than positive infinity. And then we're going to have so that's set notation. Who remembers interval notation? Anybody remember? So it's where you do the parentheses or you do the brackets. Who remembers when do I use a parenthesis, when do I use a bracket?
It depends on whether you include the
Good. It depends if whether that point is included in the solution or not. Can we ever reach negative infinity or positive infinity? No. So it's both parentheses. So this is negative infinity, comma, positive infinity. Close our parenthesis. You do need to know both notations. You need to know set notation and interval notation, and we're going to keep practicing it. So that's the domain, but I didn't just ask for the domain. What else did I ask for? The range. So now when I'm looking for the range, we're not looking left, right. Now we're looking up, down. So I have to look at my lowest point on this graph. What is the lowest point on this graph? Isn't it this point right here? That is an actual point. What is that point where the x and y axis cross? 0. So do we agree the lowest point on this graph is at 0? Is 0 included, and how do you know? Ariana? Good. Yes, because it's a closed circle. So what we're going to do is say we're starting at 0. That's our lowest point. What's the highest point? So its highest point is left, highest point right, it doesn't matter. But I look at both highest points, aren't they both arrows? So doesn't that mean I'm going up forever in both directions? So what is going up forever? Infinity. So there's two ways we can do this in set notation. You can say, I can't say x anymore because it's not the domain. What is it? Y, because we're talking about the range. And I will take points off the test if you call range Y, just an FYI. Call range X, just an FYI for you. So you could say Y such that, and you could just say Y is greater than or equal to 0. I would absolutely accept that. If you wanted to be a little more formal, you can say Y such that 0 is less than or equal to Y, which is less than positive infinity. How come I didn't put a line under the less than or equal to infinity, Ariana? You can never reach infinity, exactly. Now, if I were to write this in interval notation, what you're going to do, because 0 was included, you're going to do square bracket 0, comma, infinity, parenthesis. And I use the square bracket on the 0 side because the 0 is included. If that was an open circle, I would do parenthesis on the 0 side. Okay, next one. Same directions. Oh, sorry, I forgot to answer the last question. Is this a function for letter A? Yes. Okay, so for letter B, I want our domain. So we're going the furthest left first, right? Domain is left, right. Always start furthest left. What's the furthest point on the left? Or the furthest number on the x for our x axis? Yes. -1. Is -1 included or not included? Not included. So if we're setting set notation, and I cannot tell you what set notation versus interval notation. So if I'm telling you set notation, it's going to be x such that -1 is less than x. I'm not doing equal to because it was an open circle, which is less than or equal to, and the furthest left we go, furthest right we go, that should be a 3. Can somebody tell me the interval notation for domain, Charlie?
Parentheses, -1, comma, 3 bracket.
Perfect. Parenthesis -1 comma 3 bracket. All right, can somebody tell me what is the range in set notation? What is the range in set notation? Well, my lowest point is -1, so it's y such that -1 is less than y, which is less than or equal to 3. It is just a coincidence that my domain and range have my same reference numbers. That's just how I did it. So again, it's going to be -1 comma 3, parenthesis bracket. Is this a function? Yes, absolutely, it is a function. Let's do one more. Okay, somebody tell me the domain and set notation. Shiv, tell me the domain and set notation. Perfect. X such that x is greater than or equal to -2. That's perfect. Ali, tell me the interval notation for the domain. And what about parentheses or brackets? Well, tell me the number because your left and my left are different.
-2 bracket.
No, bracket for -2 because it's included. And we can't have a parenthesis, we can't have a bracket for infinity because we can never get to infinity, can't touch it. Okay, now the range. Leo M, can you tell me what's the range in set notation?
What's the
But does it matter?
oh, yeah, there's negative y such that negative infinity is less than 1.
Perfect. Janky, could you tell me the interval notation for this? Perfect. Okay, so we're good with domain and range. Oh, sorry. Is this a function? Good. Why? It does not pass the vertical line test. Is it a function? No. It fails the vertical line test, which means what? What does that mean if it fails the vertical line test? Lily? Good. It has a repeating domain. It has a repeating x value. Okay. Let's stuff with the domain in series. Let's talk about composite functions. Actually, no, I don't want to talk about composite functions yet. Let's talk about the domain and zeros of a rational function. So we're going to talk about domain. Uh-oh. Okay, so generally speaking, if I just give you a rational function, our domain will be all real numbers unless there's something that's going to restrict it. So let's talk about that. So the domain is generally the set of all real numbers except those that make the denominator 0 or create an imaginary number. Okay, so let's say I have this function f of x equals 1 over x plus 1. Generally speaking, if I just give you some function, f of x equals some expression, it's going to be all real numbers. This is going to be all real numbers. The domain is going to be all real numbers, except, now let's see. If I have a variable in the denominator, now I have a risk of that denominator being 0. And can I ever have a 0 in that denominator? No. Also, if I have an imaginary number, well, what would create an imaginary number? Good. If I have a square root and a variable under that square root, now I have a risk of getting an imaginary number under that square root, which would make it imaginary. So those are the two scenarios that will affect our domain from being all real numbers when given a function. So in this scenario, we are affected because I have that denominator, a variable in that denominator. There's something that can make that denominator 0, which is undefined. So guess what? My domain will be all real numbers except what number? -1 because -1 will make my denominator 0. So the domain here, all you would write is x cannot equal -1. And by me writing x cannot equal -1, it implies that every other number is okay except -1. And if you look, and I know we're not graphing, but eventually we will be graphing, I'm going to show you in Desmos what happens there. Wait, what was it? X plus 1?
Yeah.
There we go. I knew that was a little off. Okay, so now if you look at this graph, I want to also draw the line. Yeah. All right, so I drew the line x equals -1, so you could see this is all the values where x equals -1. Do you notice our graph of this function? It's getting really, really close to that -1, but is it ever touching it? Never. It can never touch it because if it were to touch it, it's undefined. It's not allowed to be there. So that's what would affect it. Now, whereas if I give you something, I don't want that. If I give you f of x is equal to x plus 3. So remember, if I'm asking you the domain, your go-to is, the domain is all real numbers. That's your go-to. The domain is all real numbers, except if there's something that will make a denominator 0 or something that can create an imaginary number. Well, in this function that I gave you, f of x equals x plus 3, is there any of those restrictions? Anything that will make it a denominator of 0 or an imaginary number? No, since there's none of those restrictions, what would be the domain here? The domain is my all real numbers. And how do we represent all real numbers? The infinities. So let's go here and see. What did I write down? X plus 2? 3. Plus 3, okay. And there's our line. Is it ever stopping? Never stopping, right? So that is all real numbers, negative infinity, positive infinity, yes. Yep, I would accept the R, absolutely. I would accept the R for that. Okay, so that's the domain. And the last thing we're going to talk about today are the zeros. Okay, so the zero of a function is the set of real numbers or say the set of the domain that makes the outcome, or the output, I should say, makes the output, which is Ry, 0. So let's say I have x over x plus, f of x equals x over x plus 2. Do we agree that f of x and y are interchangeable? That y is the same as f of x and f of x is the same as y? So I can always write this as y equals x over x plus 2. And I want us to find the zeros. So now for me to find the zeros, I need my output, which is y, to be 0. So what am I going to do? I'm going to set my function x over x plus 2 equal to 0. And what am I going to do? Solve for x. Now, can I ever have the denominator be 0? I can never have the denominator be 0. So we cross multiply, we get x equals 0. And isn't that all we have? I don't have to worry about that denominator because I don't want it to be 0. So essentially, when I'm giving you a function, in order for us to find the zeros, do I care about the denominator equals 0? We don't want that. That affects the domain. So essentially, all I'm doing is setting the numerator equal to 0. That's really what we're doing, right? Once that numerator is 0, then isn't that outcome going to be 0 because 0 divided by anything is 0 anyway? So let's see. This is saying the graph is going to cross at x equals 0. So go to Desmos. I have y equals x over x plus 2. Where's that? It's got in here. Get normal numbers. Let's get a new one here. No, I don't want to save this. I don't know how to do this. Up here. There we go, much better. Okay, and so where am I crossing? This is my 0, where I'm crossing the x-axis at x equals 0. All right, this is where we're going to stop. We're not done with the lesson, so no homework.